Welcome to solverfy.
Question 62 is a KSP and molar solubility question with various parts. It always helps with these types of questions that we write the KSP equilibrium expression. In this case, it would be m2x going to 2 m pluses and 1 x2 minus. The KSP expression would be m plus squared, because of the coefficient 2, multiplied by the x2 minus concentration. The molarity of the m plus concentration will be equal to 2 times molar solubility, because every time 1 mole of the solid dissolves, we get 2 moles of the ion m plus. However, the concentration of X will simply be equal to molar solubility, because every time 1 mole of the solid dissolves, we get 1 mole X2 minus. So knowing molar solubility, we can solve for the concentration of M plus. It will simply be 2 times molar solubility, or 1.0 times 10 to the negative 4, while the X2 minus concentration will simply be equal to molar solubility, or 5 times 10 to the negative 5. The KSP expression then can be written as we did before, and substituting in 2s for m plus and s for x2 minus. This gives us KSP being equal to 4 times s, the molar solubility, cubed, or numerically, knowing the molar solubility, it would be 5 times 10 to the negative 13. When carrying out these calculations, we must assume that m2x partially dissociates into its ions, and there's no other source of x2 minus and m plus. If there is another source of x2 minus and m plus, then the values that we calculate will be incorrect. And the KSP value will be slightly higher than the actual value. We also need to make the assumption that x2 minus does not behave as a base, and that m plus does not behave as an acid. These assumptions rarely are true. Anions often do behave as bases, and cations often do behave as acids. This will also affect the KSP value that we calculate.